1.73. So if I take 1.73 and I subtract 2 from it, so like minus 2 plus the square root of 3 is approximately, stupid calculator, minus 0.26, all right? On the other hand, minus 2 minus the square root of 3 is approximately I'll get it eventually. Minus 3.73-ish, all right? So I think it's worth our time to do that so we make sure we put them in the right place on the number line relative to the other numbers, right? Because the best way to compare numbers is to look at their decimal expansions, right? So this one is the first, minus 2 minus square root of 3. That's the furthest over. And then comes next is minus 3. And then after that, we run into the, minus 2 plus the square root of 3 critical number. And then way over, well, not way, but anyway, somewhere over here. I'm not trying to keep a sense of scale on this picture, okay? 3 is over there. I'm just trying to make sure I have them in order. So my picture is going to be a little bit, Okay, so then what? Let's plug in some points. If I plug in, so what happens here? Do I start out plus or do I start out minus? Like what goes on here? Think about plugging in a big number that's bigger than, 3. Like if you plug in 4, it's usually pretty easy. What happens when you plug 4 into the formula? Plugging 4 into the denominator is clearly positive, right? 16 plus 16 plus 1 is 33 or whatever. The denominator works out to 33. If I plug in 4 into the numerator, though, I get 9 minus 16. That's negative, right? So this expression starts out negative. All right, now you guys help me out. What happens next? Do I flip signs? Actually, let's just take a long look ahead. Every single factor here is not repeated, right? Every factor in this expression happens just once. That means every critical number, we flip signs. So we're going to go minus to plus, to minus, to plus again, to minus. It's often been helpful to know what the Y-intercept is. What is that here? That's something I might ask you to find on your graph. Intercept. Find Y-intercept. F of 0. What is F of 0? Which one of these formulas do you want to use to calculate F of 0? I mean, you got your choice. You could use this one, you could use that one, you could use that one, you could use that one. I think I'll use the first one. That's easiest. If I plug 0 into that, what do I get? 9 minus 0 over 0 plus 1. So my son, like my oldest son, when I'm teaching him math and I write this kind of stuff, he's like, don't need to write that. I'm like, fine, 9. Yes, it's true. You could just see 9 without writing all that. Fair enough. So the Y-intercept is 9. All right, so this guy, this minus 2 plus root 3 is awful close to the y-axis. It's a little bit to the left of it, so I'll try to keep that into consideration in my graph. Let's see here. I got vertical asymptotes where? What'd I say? At the annoying ones, right? So vertical asymptotes at the minus 2 plus or minus root 3 ones. So I got one here and one just about right here. Again, I'm not quite capturing the scale. I'm just doing the best I can. All right. Minus 2 minus square root of 3 minus 2 plus square root of 3. Where is my horizontal asymptote? It's at minus 1, right? So let's put that in. So that's something like this. That was supposed to be a straight line. Oh well, I try. And what else do we got? we got some x-intercepts this time, right? We have an x-intercept at -3 and 3. So I'll put that in. X-intercept, x-intercept, all right. Then what? What else can I do? Oh, I know my y-intercept was what? 9? So that's like up here somewhere, I guess. Right? Okay, so then how does this work? What do we got? Let's draw it. Let's graph it. We're negative over here. Something like that. Yep. And then we're positive on the other side. We cross through that x-intercept, right? Like that. And then we go down. And sometimes we got to kind of turn around because we're going to go down, 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 down like that. All right. Something like that. And then what happens on the other side of the -2 plus √3 vertical asymptote? Well, we're positive again, right? So we're up here somewhere. We cross through that y-intercept of 9. And then we cross through this 3. And then apparently we kind of just drift into that horizontal asymptote like that. So there you go. This is roughly, and of course, this is not straight. That's just me not being able to graph worth anything on the whiteboard. It's probably more like this. So sometimes if I make a dotted line, I can do better. You know, if I want it to be pretty. You might ask, am I going to grade on prettiness? Well, yes and no. There comes a point where it's so sloppy that I can't see the math for the squiggle, you know? So there are limits to my looking the other way on sloppiness on the graphing. I do try to see, I try to look at, you know, glass half full kind of thing with graphing. I try to see you seeing something correctly as opposed to just going, you know. But anyway, there are always people who have a higher standard of like graphing clarity than a given person, you know. I'm sure there are people who think everything I graph is garbage, you know. But I can do better on paper, I will say that. So any questions? Listen, so next time what we're going to do is I think I'm going to break you guys into groups, and I'm going to like maybe 3 or 4 of you. Let's see, we got 1, 2, 3, 4. How many boards in here? We got what, 5 boards in here, so let's use them. I'll probably break you guys up into like 10 groups, give you 10 different problems to graph on the board, and then you'll graph them, and then we'll take the end of class to talk about how it went, what went right and what went wrong, and we'll criticize all each other's work, all right? So there's going to be some time pressure. Like I need the graphing for the 10 groups to happen, you know, relatively quickly so we have time to talk about all 10 problems. But I think if we do that, then that way it gets you guys involved, because I can keep doing these all day long, you know. It's kind of like, you ever go to like a piano, what are those piano concerts called? They got a special name. Recital. The recital? There's a fancier name for like the really, really hoity-toity recitals. What are they called? Concerto? Yeah, the concerto. Like you don't go to a piano concerto and then like walk away from it and go, man, I can play Rachmaninoff now. My hands grew like an extra 20% and like all of a sudden I can reach these chords. Like that doesn't happen, right? The only way you get to play that kind of stuff is what? From practicing. Same with math, right? I can show you some of the, you know, ways to do things, but ultimately you guys got to practice. So